Today we're going to talk about hypothesis tests for two sample proportions. The typical hypothesis test for the difference in two proportions is the one of no difference. In symbols, means H sub O is P1 minus P2 equals 0. Since we are hypothesizing that there is no difference between the two population proportions, that means that the standard deviations for each proportion are the same. Since this is the case, we combine or pool the counts to get one overall proportion. The pooled proportion is P hat equals success 1 plus success 2 over N1 plus N2, where success 1 is equal to N1 P hat 1 and success 2 is equal to N2 P hat 2. If the number of successes are not whole numbers, round them first. This is the only time you should round values in the middle of a calculation. We then put this pooled value into the formula, substituting it for both sample proportions in the standard error formula. So the standard error of P hat 1 minus P hat 2 is equal to the square root of P hat Q hat times 1 over N1 plus 1 over N2. The conditions for the two proportion z-test are the same as the two proportion z-interval. We are testing the hypothesis that the null is P1 equals P2. Because we hypothesize that the proportions are equal, we pool them to find P hat. Now we find the test statistic. Z equals P hat 1 minus P hat 2 divided by the square root of P hat Q hat times 1 over N1 plus 1 over N2. When the conditions are met and the null hypothesis is true, this statistic follows the standard normal model, so we can use that model to obtain a p-value. Let's look at an example. A survey of randomly selected college students found that 50 of the 95 freshmen and 52 of the 107 sophomores surveyed had purchased used textbooks in the past year. Do the data provide sufficient evidence there is a difference in the proportions of college freshmen and sophomores who purchased used textbooks? So, step one, we have our hypothesis. We need to define our parameters. P1 equals the population proportion of freshmen purchased used textbooks, and P2 is the population proportion of sophomores that purchased used textbooks. Our null is P1 equals P2, and our alternative is P1 does not equal P2. Checking our assumptions and conditions. We have a simple random sample. The population size is greater than 10 times the sample size for both samples. And N1 P hat 1 is equal to 50, and N1 Q hat 1 is equal to 45, which are both greater than or equal to 10. N2 P hat 2 is 52, and N2 Q hat 2 is equal to 55, and those are both greater than or equal to 10. Calculating the test. We have to pool to get our proportion. P hat's going to equal 50 plus 52 divided by 95 plus 107. That gives us a P hat of 0.505. So our formula, plugging in our numbers, we have 50 over 95 minus 52 over 107 divided by the square root of 0.505 times 0.495 times 1 over 95 plus 1 over 107. We get a z of 0.5723. Drawing our normal curve, shading both sides since we have a two-tailed test. One side is going to give me a p-value of 0.284. The probability that our sample proportion difference is 0.04, given that our population proportion difference is 0, is 0.568, which is the double of the right side p-value. So our conclusion is we're going to use an alpha of 0.05. Since p-value is greater than alpha, we fail to reject that there is no difference in the population proportions of college freshmen and sophomores who purchase used textbooks. Second example. In a random sample of 360 women, 70% favored stricter gun control laws. In a random sample of 220 men, 60% favored stricter gun control laws. Test the claim that the proportion of women favoring stricter gun control is higher than the proportion of men favoring stricter gun control. Use a significance level of 0.05. So our hypothesis, stating our proportions, P1 is equal to population proportion of women who favor stricter gun control, and P2 is the population proportion of men who favor stricter gun control. Our null is P1 equals P2, and our alternative is that P1 is greater than P2. Checking our assumptions and conditions. Simple random sample is stated. Population sizes are greater than 10 times our sample sizes. And our N1 P hat 1, which equals 252, our N1 Q hat 1, which equals 108, are both greater than or equal to 10. And our N2 P hat 2 and N2 Q hat 2 are both greater than 10 as well. So calculating test, finding our pooled proportion, we get 0.662. So z equals 0.7 minus 0.6 divided by the square root of 0.662 times 0.338 times 1 over 360 plus 1 over 220, and we get a z value of 2.47. So we're going to draw our line at 2.47 and shade to the right. Our p-value is 0.0067. So the probability that we get sample proportion difference of 0.1 given that there is no difference in the population proportions is equal to 0.0067. So our conclusion, we're given that alpha is 0.05. Since p-value is less than alpha, we reject that there is no difference in the population proportion of women and men who favor stricter gun control. Don't use two sample proportion methods when the samples aren't independent. These methods give wrong answers when the independence assumption is violated. Don't apply inference methods when there was no randomization. Our data must come from a representative random samples or from a properly randomized experiment. Don't interpret a significance difference in proportions casually. We've now looked at the difference in two proportions. Perhaps the most important thing to remember is that the concepts and interpretations are essentially the same, only the mechanics have changed slightly. Hypothesis tests and confidence intervals for the difference in two proportions are based on normal models. Both require us to find the standard error of the difference in two proportions. We do that by adding the variances of the two sample proportions, assuming our two groups are independent. When we test a hypothesis that the two proportions are equal, we pool the sample data. For confidence intervals, we don't pool.